Hi, this is Mr. Pablo, and today you're going to learn about probability of two events, this time with another different method. Okay, so far we have learned two methods, by listing, and the other one is by using a table. Now this is going to be the third and the last method for this topic, so you have to really pay attention. Now, let's look at the problem. Two fair coins are tossed at the same time. Complete the tree diagram to show the possible outcomes. Now, the tree diagram, or it should have said something like complete the question using a tree diagram. Okay, so something like that. So we're gonna make our tree diagram now. Okay, and what's a tree diagram? A tree diagram is like a tree with branches, only that it doesn't really look like a tree, but it somehow has a lot of branches, which is why it was called a tree diagram. I'm going to show you how to make it. Alright, so two fair coins are tossed. So basically, there will be first coin. Okay, this will be the first coin, and this will be the second coin. They're going to be tossed at the same time. Okay, so now let's think about a coin. Now, a coin has only two outcomes, really. It's either heads and tails, right? So, outcomes of a coin is just either heads or tails. Nothing really much after that. So now, because we know the outcomes, then we are ready to draw the tree diagram. So the tree diagram looks like this. Okay, now first coin. Alright. Okay, it's just either again heads or tails. Okay, so like that. Heads or tails. Okay, now if you think about it, what is the probability of obtaining a head? Okay, so how many heads do you see in a coin? Well, there's only one head out of how many outcomes? Heads and tails, so that makes two outcomes. Okay, so what about tails? How many tails do you see in a coin? There's only one tail over there out of the two outcomes, which is head and tails. Okay, so the probability of obtaining a head is 1/2, and the probability of obtaining a tail is also 1/2. Okay, now that's the first part of our tree diagram. So this time, I'm just going to drag this over here so that we save some space. Okay, or perhaps I have to drag it over here so that we have everything in the right place, and maybe if I just try to move everything here so that we really save some space. Okay, right, now this is the second part of our tree diagram. Okay, now the second coin can also have some heads and tails. Okay, so I have to extend my tree diagram into something like this. Okay, again there will be two outcomes. Okay, so for example, the first coin landed on head, the second coin can land on a head as well, and for example the first coin landed on a head and the second coin can land on a tails. Okay, that's another probable outcome. Same thing here with the tails. If the first coin landed on tails, the second coin can land on a head. And another situation can be if the first coin landed on tails, the second coin can land it on tails as well. So that completes my tree diagram. But really, I also have to fill up all the values over here. Now again, on the second coin, same as the first coin, the probability of obtaining a head again is also 1/2. Okay, and the tails is also 1/2. Also here will be 1/2, and also here will be 1/2. Okay, the probabilities will not change. because it's just either heads or tails, unless there are some conditions written in the problem that will make them change. But in this case, it's just like this. So let's write down all the outcomes, shall we? Okay, so here we go. Here are the outcomes. Okay, what's the probability that the first coin will land on a head, starting here, and the second coin will also land on a head? Okay, if we try to track it back on our tree diagram, the first coin landing on a head and the second coin landing on a head, so HH, that's the first probability. Now what sum can we think of? The H here is 1/2 and the H here is also 1/2, and what we need to do with those two fractions is to multiply them. So 1/2 times 1/2, type it in your calculator. 1ABC2 times 1ABC2 is equal to 1/4. Okay, if you know the rules of fraction is to just multiply the numerators and denominators across. 1 times 1 is 1, 2 times 2 is 4, that's why it's 1/2. Okay, right, now that's one probable outcome. For those two coins to land on a head and another head, the probability is 1/4. Okay? Now, what is the probability that the first coin lands on a head and the other coin lands on a tails? Okay? So again, similar situation. It's going to be 1/2 because it says 1/2 here, times 1/2 again because the tails has an equal probability with the heads, and therefore it's also 1/4. Okay, and another probable outcome is that the first coin lands on the tails and the second coin lands on the heads, so that will be 1/2 times 1/2, which is equal to 1/4. Okay, good. And the last question is, the last probability, sorry, is that the first coin lands on a tails and the second coin lands on another tail. So that is also 1/2 times 1/2, which is 1/4. Okay. Now, if you think about it, all the possible outcomes should be equal to 1. Now, because that's probability, it should all add up to 1. If you go back to the probability scale video that I made, probabilities are ranging only from 0 to 1, and 1 is the highest number. So if we check, if we add all these fractions out, all these probability fractions, and then it should equal to 1. So try it in your calculator. 1/4 plus 1/4 plus 1/4 plus 1/4, it should all equal to 1. And you should find out that it is equal to 1, therefore you can say that you're safely correct. Right, so that is the probability tree, really. Okay, and now we have answered that. We've shown a tree diagram, and we've also shown all the possible outcomes, and we've calculated all the possible outcomes as well. So that ends my lesson with probability of two events using a tree diagram. Using a tree diagram. Okay, hope you learned something from that, and thank you for watching my video.